let's take a look at the region bounded by these two functions. Now what we're going to do with this region is we're going to rotate it about the y-axis, and to do that we're going to use the shell method. And with the shell method what we do is we slice up our region parallel with the axis that we're rotating around, and we take each one of these little slices and we rotate it around, in this case the y-axis, to create a thin shell volume. Then what we're going to do is we're going to slice this thing up over and over again in this region, create all of these little thin shells, then we're going to add the volumes of all of those shells up to get the volume of the region that we're looking for. I'm going to get rid of this last one because it looks a little bit messy. Let's find the volume of this shell. Well, first you might notice that the thickness of this shell is dx. That means we're going to be integrating with respect to x at some point. So the volume of the shell is going to be 2 pi r. You might remember that as the circumference of a circle, times the height of this thing, then times the thickness dx. The total volume then is going to be the sum of the volumes of all of these little shells. And to find that sum, what we do is we integrate. We're going to integrate from x equals 0 to x equals 10, and we're going to integrate with respect to x. So we want all x's in this integrand. And you'll notice from the picture up here that the radius of each one of these shells is just determined by each x value from 0 to 10. In other words, if we drew all of these shells in, the smallest shell would have a radius of 0 and the largest shell would have a radius of 10. So we're just going to say our radius is x. The height of each one of these shells, you'll see from this graph, is given by the function 10x minus x squared. Now to complete this problem, we need to integrate, plug in our limits, and get an answer. First, I'll distribute this x through the parentheses. Then we can integrate using the power rule. Now we can plug in our upper and lower limits of integration. And we can simplify. Simplifying all of this is going to give us 5,000 over 3 pi and the approximate value of 5,236 cubic units. So that is our answer. I'm going to zoom out so you can see all of the work that we did on that problem. In our last Calculus 1 problem of the day, we're going to do a problem where we use both the shell method and the disk/washer method to find a volume and make sure that we get the same volume using both methods. I will see you there.